Welcome once again to the class and welcome once again to the channel. Today we will move on towards our next lecture of physics optional, and the concept which we are going to start is that we are going to revise a little bit the concept given as below, that non-inertial frame means that laws of motion do not hold in it. You have already learnt, right, that in non-inertial frame laws of motion do not hold, and non-inertial frame accelerates with respect to an inertial frame. This also you have already learnt, right? Let me see if the recording is on or not. Yes, so the recording is also on. So non-inertial frame is that frame in which laws of motion do not hold and it accelerates with respect to an inertial frame. Now fictitious force, inertial force or pseudo force. Now what is this? Let us see. Now all these terms imply the same thing. Fictitious force also means the same, inertial force also means the same, and pseudo force also means the same. Okay. So pseudo force is the force which acts in a non-inertial frame. But remember one thing, that we are calling it to be inertial force. We are calling it to be inertial force, not non-inertial force. Okay, so we are calling it inertial force. Now let us suppose such is the situation which is given to us. Now suppose this is your y-axis, this is your x-axis, and this is your z-axis, suppose. And this z-axis is coming out of the plane from this particular point O. Where is this z-axis? It is coming out of the plane from this particular point O. Okay. And mass m has been kept over here on this OX axis. Mass m has been kept, and it is being attracted by the earth by a force equal to mg. And n is the normal reaction acting on this particular mass. Okay. And this S is your inertial frame, which is the stationary frame. Let us assume that this inertial frame is, what is an inertial frame? Inertial frame is a frame which is either stationary or moving with a uniform velocity, right? So this S is an inertial frame, but such an inertial frame which is stationary, not uniform velocity. Okay, this S frame is suppose stationary. Just for simplicity, we are assuming that S frame, that is your inertial frame, is stationary. Okay. We will also consider the case when it will move with a uniform velocity. That case also we are going to consider, but we will consider that later on. But for the time being, just see that this S inertial frame is stationary, and this S prime is what? It is a non-inertial frame. Okay, this S prime is a non-inertial frame, and someone is sitting inside this frame. Some person is sitting inside this frame, and this frame S prime is moving along the x-axis with a constant acceleration equal to a naught. A naught is the constant acceleration of this frame S prime, and this frame S prime is present inside a vehicle. Okay, this is a vehicle. So S prime frame is present inside a vehicle, and this vehicle is equal to S prime frame in itself, and it is moving in the right direction, that is along the OX direction, means in this particular direction, Okay, along the I cap direction. We can call it to be I cap direction, right? So it is moving along the I cap direction with a constant acceleration a naught. And this thing has been shown twice over here, but there is no significance of it being shown as twice. Okay, so one time over here and one time over here, so it is being shown two times, but there is no significance of it to be shown two times. Now resultant force on the body B, what is it? This resultant force on body B, as you can see from the free body diagram, the resultant force on this body B, what will it be? It will be equal to F equal to mg plus n. Okay, this mg is in the downward direction, n is in the upward direction. So mg vector plus n vector equal to f vector. Okay, mg vector plus n vector equal to your f vector. Now removing the vector sign, what will you get? This mg is in the downward direction, this normal reaction is in the upward direction. So what will you get? You will get negative sign over here. Okay, minus sign. Let me draw properly. Minus sign over here. Okay, that is mg minus n will be there. So mg plus n, so this will be mg vector plus n vector. So removing the vector sign and taking the downward direction as positive and upward direction as negative, what will you get? F vector sign removed equal to mg minus n. Okay, this green symbol shows minus sign, negative sign. Okay, minus mg minus n, as mg is anti-parallel to n. So they have opposite signs, that's why, and that is equal to your 0, because this is a assumption, or we can say actually the normal reaction is equal to the weight which is weight of the body, okay, weight of the body on a particular planet. The normal reaction is equal to weight of the body approximately, okay, approximately I am saying, although in strict sense there might be some deviations in strict sense, but as far as our classical mechanics is concerned, so your normal reaction will always be equal to the weight of the body in the downward direction, okay. So mg equal to n, so that's why the force acting on this particular body will be equal to 0, but with respect to which frame? With respect to this S frame, okay, we are talking with respect to this S frame, okay. Now equation of motion in S, what will it be? F equal to ma, right? F equal to ma. Now we are going to write the equation of motion of this particular mass m with respect to this S frame, that is the inertial frame. So what will it be? Equation of motion in inertial frame S, what will it be? F vector equal to ma vector, okay. So this is how the equation of motion is written always, that is the external force equal to ma vector. Now your resultant force is equal to 0 because mg and normal reaction have already yielded you force to be equal to 0, okay. Mg and normal reaction both are in the opposite direction, so that's why the force, resulting force is equal to your 0, right? So equation of motion in S, F equal to ma, so it will be equal to 0 equal to ma, that implies your A equal to 0, right? So your mass will go in the division over here, and this A vector equal to 0, okay. What is this A vector? A vector means the resultant acceleration on this particular mass with respect to inertial frame. So your A equal to 0, as you already know that when product of two quantities equal to 0, when product of two quantities is equal to 0, what is the case? Either m can be 0 or a can be 0. If the resultant product of m and a is 0, then either m can be 0 or either a can be 0. But we know this very well that in classical mechanics the mass of a body will always exist. Mass cannot be equal to 0 in classical mechanics. So that's why as we are learning classical mechanics, that is Newtonian mechanics, so this particular quantity m will not be equal to 0. So eventually your acceleration a vector should be equal to 0 as m not equal to 0, right? A equal to acceleration of b relative to s. What is A? A is your acceleration of b relative to s. Now this is the body B which you have, and with respect to this inertial frame S, it is having an acceleration equal to 0 because it is stationary with respect to this stationary frame, with respect to this inertial frame, okay. So the force equal to 0 and acceleration is also equal to 0 when force equal to 0 on this particular body. So when force came out to be equal to 0, so acceleration was also equal to 0 because this was being taken with respect to inertial frame, right? So F equal to ma holds in this particular S frame, that is inertial frame, right? Acceleration of the body relative to S prime, what will it be? Acceleration of the body relative to S prime, that will be equal to your ABS prime, okay. Acceleration of the body with respect to this S prime frame which is moving with a constant acceleration a naught in this particular direction. So acceleration of this particular body with respect to this S prime frame, what will it be? You know this very well that what do you know? When you have to find out velocity of body 1, okay, with respect to body 2, what do you do? V1 minus V2, okay. What is this? Velocity of body 1, okay. This is what? Velocity of body 1 with respect to velocity of body 2. So you write V1 minus V2. What is that? That is velocity of body 1 with respect to body 2. Now you have to find out the velocity of body 2 with respect to body 1. Then what will happen? V2 minus V1 will come. V2 minus V1 will come, okay. Because V21 means velocity of the body 2 with respect to body 1. So body 2 velocity minus body 1 velocity, that will be equal to V21. Similarly, apply the same logic over here. What is your acceleration of B with respect to S prime? Now acceleration of B with respect to S, if I call it, then what will it be? Suppose I call it like this, that acceleration of B with respect to S, then what will it be? Acceleration of B minus acceleration of S, okay. This will be equal to ABS, that is acceleration of body B with respect to S frame. But S is your inertial frame, right? S is your what? Inertial frame. So as S is an inertial frame, so this will always be 0. This will always be 0, right? This particular term will always be 0 because S is an inertial frame. So your acceleration of body B with respect to S comes out to be equal to the acceleration of the body itself. That is the real acceleration of the body. Okay, real acceleration of the body. But if we try to find the same thing with respect to s prime, what will happen? So with respect to s prime, if I want to find out, then a b s prime vector. Okay, so acceleration of body b vector minus acceleration of s prime vector. Okay, so acceleration of s prime vector, what does it mean? Now already this is not equal to 0 clearly, because your s prime is moving along the right side, that is along the I cap direction with respect to inertial frame s. So the absolute acceleration with respect to inertial frame, the acceleration of this s prime vehicle with respect to inertial frame is not equal to 0. So this term will not vanish. Okay, this term will not vanish, it will not vanish, it will remain, it will remain. Okay, so as this particular term a s prime will remain, so a b s prime will not be equal to a b. Okay, because a s prime is not equal to 0, right? Because a s prime vector is not equal to your 0. Okay, so this is the thing. So now applying all these things in this particular your equation, so what is there? So acceleration of body related to s prime equal to a b acceleration of a b s prime. Okay, so b relative to s prime. Okay, acceleration of body relative to s prime. And if we wanted to find out the acceleration, what is the acceleration of s prime relative to body, what will it be? Acceleration of s prime relative to body, if I want to find this out, okay, what will it be? Acceleration of s prime relative to body, what will it be? So clearly acceleration of s prime with relative to body will clearly be equal to what? A s prime b. Okay, vector a s prime b will be the acceleration of s prime relative to body, and acceleration of body relative to s prime is what? Acceleration a b s prime. So the thing relative to which you have to find out the acceleration, that term comes in the afterwards. Okay, so you had to find out with you had to find out relative to b over here, that's why b came afterwards. You have to find out with respect to s prime over here, so that's why s prime came afterwards. So the relative to which you have to find out, that term comes in the afterwards. Okay, and the thing the entity whose acceleration you have to find out, that term comes in the first place, and with respect to whom you have to find out, that comes in the later place. Okay, so that is the thing. So acceleration of b with respect to s prime equal to ab vector minus as prime vector equal to, now this ab vector it is equal to clearly 0, because we are taking this with respect to inertial frame. AB is also with respect to inertial frame, as prime is also with respect to inertial frame. So AB is also with respect to inertial frame s, and as prime is also with respect to inertial frame s. Okay, now your acceleration with respect to inertial frame s is equal to 0. So this is the term which is equal to 0, and your as prime negative sign is over here, that's why negative sign will come. Then your as prime is equal to a naught clearly. Okay, as prime that is equal to a naught vector clearly. So 0 minus a naught vector. Now ab s prime equal to minus a naught, that is not equal to 0 clearly, because this particular term is not equal to 0. Okay, because the acceleration of the vehicle is non-zero, right? So it will not be equal to 0. So to an observer in frame s prime of force f naught equal to minus m a naught. Now what will the force be equal to? As the acceleration of this body b, what is the acceleration of this body b with respect to s prime? To an observer in the frame s prime, the acceleration on this body b is a naught in the backward direction. Okay, to observer, this particular observer sitting over here, the acceleration of this body b is a naught in the backward direction. Okay, acceleration of this body b is a naught in the backward direction. Okay, as it is itself moving in the forward direction with a constant acceleration a naught. So it appears that this body b is moving in the backward direction with constant acceleration a naught to an observer sitting over here. Okay, so that is the thing. Now certainly as there is acceleration visible to the non-inertial frame observer, as there is non-zero acceleration, as there is a non-zero acceleration visible to an observer in non-inertial frame, so clearly there will also be a force with respect to that observer which is acting on that object. So to an observer in frame S prime of force F naught equal to minus m a naught. Okay, you will multiply this by m clearly. So to an observer in frame S prime of force equal to F naught equal to minus m a naught will appear to be acting on the body, whereas for an observer in the frame S there will be no force acting on the body. So this is clear. Okay, to an observer in the frame S prime of force equal to minus a naught. Okay, vector in the opposite direction. Okay, he himself is moving in this direction, that's why the acceleration vector of body B is appearing in the backward direction. Okay, so to an observer in the frame S prime, body B has a non-zero acceleration, but to an observer in the inertial frame S, the body B has zero acceleration. Okay, so in inertial frame zero acceleration, in non-inertial frame minus a naught acceleration. Okay, so to an observer in frame S prime of force F naught equal to minus m a naught will appear to be acting, whereas for an observer in the frame S there is no force acting on the body. Now what is this particular force? Okay, if I try to say to this particular observer, if someone asks this particular observer that who is the agent of this particular force? Okay, over here with the acceleration a naught, this particular object is going to the left hand side with the acceleration a naught according to this observer. But if you ask this observer what is the you can say agent, who is the agent applying this acceleration a naught in this backward direction, who is the agent behind this? Okay, who is the agent of this force? Certainly this observer will not be able to tell the agent of this particular force. So the force is acting without an agent, that's why it is called as pseudo force. Okay, because there is no agent applying this force, but it is appearing to that observer. Okay, so acceleration of the body relative to S prime, this is there. So F naught equal to minus m a naught will appear to be acting on the body, whereas for an observer in the frame S there is no force acting on the body. A force which appears only due to the acceleration of the frame is called fictitious force, apparent force, inertial force, or pseudo force. Okay, so force which only appears due to the acceleration of the frame, you had clearly seen that S prime itself, the frame S prime itself was moving in the rightward direction with a constant acceleration a naught. So a force which appears only due to the acceleration of the frame, in this case the acceleration of the frame S prime. Okay, the force which appeared because of the acceleration of this particular frame S prime. Okay, this particular force is called fictitious force, or apparent force, or inertial force, or pseudo force. Okay, all these four names are equivalent. Okay, all these forces are equivalent, that is fictitious force, apparent force, or inertial force, or pseudo force. All these four forces are equal. Okay, means equivalent, synonyms of each other. Okay, now one thing which you have to note is this particular term, inertial force. Okay, although the pseudo force appears in which frame? Pseudo force appears in non-inertial frame. Okay, pseudo force appears in non-inertial frame. Pseudo force appears in non-inertial frame. Still, okay, even after pseudo force being applicable in non-inertial frame, the synonymous term of pseudo force, that is inertial force, it is not called as non-inertial force. Okay, this particular term is not non-inertial force, although the force is acting in non-inertial frame, but you have to call it inertial force. Okay, you have to call it inertial force. Keep this thing in mind. Okay, pseudo force is not called non-inertial force. Okay, someone might confuse you, the examiner might confuse you. Okay, see, pseudo force is applicable in non-inertial frame, so what will the student think? Student will think that it will be called as non-inertial force, but that is not true. It will be called as inertial force instead. Okay, so keep this thing in mind. Why? Because when you apply this particular force, when you apply this particular pseudo force in the equation of motion, when you write this particular pseudo force in the equation of motion of the body, you actually apply the Newton's laws of motion in a non-inertial frame. So you make the non-inertial frame as inertial. By applying this pseudo force, you make non-inertial frame as inertial. Okay, that's why this pseudo force is called as inertial force, because it is converting non-inertial frame into an inertial frame. That's why pseudo force is called as inertial force, not non-inertial force. Okay, so the naming has been done the other way round. Okay, it is, the naming is not based on in which frame the force is acting. Okay, the naming is not based on in which frame the force is acting. Instead, the naming is based on what it is converting the frame into. Okay, so it is converting, the pseudo force is converting the non-inertial frame into inertial frame. So that's why it is called as inertial force. Okay, it is not called a non-inertial force. Why? Because this terminology has not been applied, okay, with respect to the frame in which the force is acting. Okay, so तो कुल मिला के कहना ऐसा ही है कि इनर्शियल फोर्स कहा जाता है उसको, नॉन इनर्शियल फोर्स नहीं कहा जाता. क्यों? क्योंकि वो इनर्शियल बनाता है नॉन इनर्शियल फ्रेम को, इसलिए. ठीक है ना? तो ऐसा है, उसको नॉन इनर्शियल फ्रेम नहीं कहा जाता, इसके बावजूद कि वो नॉन इनर्शियल फ्रेम में एक्ट कर रहा है वो फोर्स. सो यू गॉट इट नाउ. Remarks: pseudo force is not a real interaction. It is clearly not a real interaction. It exists only in non-inertial frame. Clearly, pseudo force equal to mass of the. So these two terms, these two statements are clear. That pseudo force real interaction, it is not real. So it exists only in non-inertial frame. Pseudo force equal to mass of the particle multiplied by acceleration of the non-inertial frame sign reversed. Okay, so you can see over here that pseudo force acting on this particular object, what will it be equal to? Look at the acceleration of this particular frame. The S prime frame is moving in the rightward direction with acceleration a naught. Okay, so the pseudo force which will act on this particular body will be in the leftward direction, that is the sign reversed. Okay, sign will be reversed, acceleration sign will be reversed. So eventually force direction, that is force, will be equal to minus m a naught vector. Okay, so the sign has been reversed. So the sign was positive over here the sign has turned out to be negative, right? So the acceleration of the non-inertial frame, sign reversed. Mass multiplied by acceleration of the non-inertial frame, sign reversed. You can see it over here also. Okay, mass into acceleration of the non-inertial frame, which was plus a naught, sign reversed. Mass into acceleration of non-inertial frame, which was positive, sign reversed. So it becomes negative. So that is the thing. So pseudo force equal to mass of the particle multiplied by acceleration of non-inertial frame, sign reversed. So this is the thing which you must remember. So now from here onwards we will do in the next class. Okay, total force equation of motion in a non-inertial frame. From here onwards we will do in the next class. So thank you very much. अपना ख्याल रखिएगा.